lived on Earth for thousands of years. In that time, they've tried to understand their place in the world and what makes them human. Through the centuries, we have learned to build great machines, to lift and bend, to forge and carry. All of these have been created by the most highly developed, efficient and superb machine of all, the human body. A light, flexible yet strong framework driven by beautifully engineered organs and made up of billions of tiny cells. Each one of us has 10,000 times more cells in our body than there are people on Earth. No machine is as complex as this one. But without one simple ingredient, it would die: air. After an accident, the first aid is oxygen, the breath of life. Ancient Greeks believed the body had at its center a flame, burning food, creating warmth. And that we breathed to cool that flame, to stop it setting fire to the body. It's our lungs that constantly take in life-giving oxygen the body can't store, exchanging it for carbon dioxide. The surface area of the lungs is huge, flattened out almost the size of a tennis court. Breathing in and out 600 million times in a life, enough to fill 400 hot air balloons. From the throat, the windpipe divides into two stems, which in turn subdivide into thousands of fine hair-like tubes. Each ends with a minute air sac to receive the oxygen and pass it into the blood. So vital is breathing to life that expiration has come to mean death. And inspiration can lead to genius. And it's genius that sets this machine apart from all others. Something exclusively human, believed by many to be the soul. And the windows of the soul? The eyes. The human camera. 2/3 of what is stored in the human brain has entered through the eyes. Sight is the body's chief sense, its guide, and its greatest guardian against predators. And just like a camera, the eyes have 3 distinct parts. A transparent outer covering, the cornea. Behind, a lens to receive light. And at the back, a screen, the retina, containing 127 million light-sensitive cells, rods and cones. Most are rod cells that work in dim light, seeing only black and white. In the dark, we have little need of color. But in bright light, cone cells suddenly flood our eyes with color vision. The eye is cleaned and disinfected by moving the lid across it. We do it over 5,000 times a day, each time for 1/3 of a second. There is another effective cleansing process: crying. Children do it more often than adults. The average 1-year-old cries at least twice a day, cleaning and sterilizing the eyes, fighting infection. Tears offer emotional cleansing too. Tears of sadness and tears of joy. A common cause of laughter, the discomfort of others. After sight, most information about the outside world reaches us through the ears. It's taken us centuries to understand hearing and to appreciate the true power of the human ear. We've learned to delight in the pleasure of sound, develop a taste for music, and revel in the rhythm of dance. Whatever the source, all sound begins with vibration. Sound waves enter the ear and reach the all-important membrane, the eardrum, a thin, taut skin the size of a fingernail. The drum sends vibrations through the body's tiniest bone, the stapes, no bigger than a grain of rice. And nerves send a signal to the brain that we recognize as sound. Many body features are not just practical. In some African cultures, ears display tribal status, and Buddha's long earlobes signified royalty and spiritual authority. King Midas got his long ears when he objected to Apollo playing the lyre, so he was judged to have the musical taste of a donkey. Ears also help us keep our balance. Tiny head movements trigger nerve signals to send information about space, motion, and gravity to the brain. So some of us keep our balance even on a beam. We use balance for one of the main things that separates us from our animal ancestors and enables one of the greatest human achievements, standing upright, the spine in a straight line and the head held erect to face the world. The body has 206 bones, more than half of them in the hands and feet. All are linked by joints and driven by muscles to produce the perfect moving machine. Our bones are strong. The thigh bone, 150 times bigger than the tiny one in the ear, is stronger, pound for pound, than reinforced concrete. Most of us live in houses far less sturdy than our thigh bone. Yet bones, so essential to our life, are also symbols of death. Another body part is even harder, the part that protects our crucial ability to take a bite, tooth enamel. So hard that it takes a dentist's drill with a strengthened tip to penetrate it. The powerful skeleton is only 1/6 of the body's weight. Almost half is what drives this set of bones. Muscles, 640 of them designed to contract and exert pressure. Muscles can achieve extraordinary feats when trained to peak form. When a bodybuilder flexes his muscles, they don't get bigger. They just shorten and swell in the middle, like a long balloon squeezed at each end. But not all muscle work is so obvious. Muscles supply the body's heat. They even help the body stand still. Neck muscles oppose each other perfectly to achieve that crucial human advance, holding the 4-kilogram head upright. And just as the teeth are the body's hardest part, so the muscle that works them, breaking down food for all-important digestion, is the body's most powerful. The jaw exerts a crushing pressure of 2 tons per square centimetre. Muscle and skeleton couldn't work together without the key link between them. Early hunters discovered, as they split animal bone and tore muscle to get at the rich nutrients, that bodies have an even tougher part. It was the joints. The mechanisms that enable humans to run, to leap, to twist and turn, converting power and strength into movement and precision. All this, yet only one organ of the body is constantly on show. It's wrapping that provides a waterproof cover, the skin. Made of keratin and covered in fine hairs, it ranges from wafer thin on the eyelids to 5 times as thick on the soles of the feet. And all over, double layered. The epidermis protects the inner dermis with its nerves and blood from water, dirt, the sun's rays, and even microscopic enemies. Typhoid bacteria can survive for many weeks, but on the skin, they die in 20 minutes. Skin renews itself constantly. Each surface particle wears away and falls off in a month. So in our lives, each of us sheds about 20 kilograms of skin, the weight of a 6-year-old girl. Across the world, millions of tons a year. And where does it all go? We see it every day, in dust. But skin doesn't just protect us. When we're cold, tiny hairs on the surface stand on end to trap air and keep us warm. Goose pimples. And when we're too hot, millions of tiny sweat pores release fluid, cooling us down. Skin is the body's outer guard, sensing touch, heat, cold, and pain. Hands and feet have tiny ridges with unique patterns which help with gripping, holding, and getting caught. Hair is also made of keratin. A head of hair is 100,000 strands or so, growing about a centimetre a month. But hair has no feeling. Luckily, otherwise a trip to the hairdresser would be like a visit to the dentist. And some hairstyles would need a full-scale anesthetic. Hair grooming has always signified wealth, status, or just vanity. When fighting, long hair can be a liability. Roman soldiers shaved before battle, and their word barber, for beard, became the word for their hairy enemies, barbarians. Nails are also keratin and grow about half as fast as hair. In 19th century Asia, long nails were a sign of great wealth. Obviously, the owner of this set certainly couldn't work. Inside the body, the rushing of blood is constant. A vast transport system that never stops carries supplies to the cells that need them. Driven by that strange organ that artists, poets, and dreamers have turned into the symbol of almost every human emotion, the heart. Early scientists thought it was a kind of furnace of blood and air. Some thought it was a fire burning the body's food. It was William Harvey in the 17th century who first realized that blood doesn't ebb and flow, but keeps circulating, driven by a steady, reliable, four-chamber pump that never sleeps, sending blood out through arteries into millions of tiny capillaries, then on into veins that carry the blood on a route back to the heart. This superb pump combines the action of muscle and valves to beat steadily 2.5 billion times in a lifetime, moving enough blood to fill the fuel tanks of 700 jumbo jets. If we dive into water, the heart slows down, temporarily reducing our need for oxygen as we hold our breath. Some believe this suggests humans originally came from water. But perhaps it's the steady beat of the heart that has made it a steady symbol through the ages. For Christians, the heart is the source of love, joy, sorrow, compassion, and suffering. Many saints are pictured holding a heart, sometimes pierced by an arrow. The Greek philosopher Aristotle believed the heart was the seat of intelligence. It's now best known as the symbol of passion. The Queen of Hearts playing card and the red heart of the Valentine have one and the same message: warmth and love. And always red, the color of blood, and therefore of life itself. Human blood is red because of its high iron content. Though not all creatures are the same. Crustaceans and mollusks have blue blood, and worms' blood is green. Some creatures live entirely on blood, the blood of others. After a long suck, a leech inflates to 5 times its normal size. But in medicine, they serve a useful function. In 1890, the French imported 40 million leeches, and doctors have recently realized leeches have an anti-clotting agent which reduces the risk of disease by thinning the blood, keeping it flowing, so the leech is now making a medical comeback. The circulation system supplies our bodies whatever the demand. As our energy needs rise, the heart's pulse quickens to match. Just where does all the energy come from to drive the body? Food, plants and meat. In the course of a lifetime, about 30 tons, the weight of 30 cows or 6 elephants. And because the body can't store energy for long, this intake must be constant. We can taste 4 distinct flavors: sour, salty, bitter, and sweet. Our choice is based on appearance and smell. As we decide, the mouth is already making saliva to soften food for chewing and help us swallow it. Saliva also kills bacteria and helps keep the mouth free from infection. We produce a liter a day, 300 bathtubs in a lifetime. The stomach is both a food mixer and an acid bath. Its walls produce a spasm every few minutes to squeeze and churn food into a semi-liquid. The workings of the stomach were first studied in 1822 by an American army surgeon, William Beaumont. A soldier's shot wound refused to heal. For the next 10 years, the doctor was able to analyze the contents of the unfortunate man's stomach. From the stomach, food travels on an 18-hour journey through 7.5 meters of intestines. There, nutrients are absorbed and the waste prepared for disposal. If our intestines weren't rolled up, we would be as tall as houses. Before they're sent around the body, the nutrients are broken down in a process controlled by our most resilient organ, the liver. Up to 80% of it can be cut off and it'll regrow. The body's most urgent need is not solid food. Without a drink, we would die within days. Fluids are purified by 2 kidneys, each the size of a fist. They filter more than a liter of blood a minute and produce 1.5 liters of urine a day. All these processes of the human machine, breathing, pumping, circulation, purifying, digestion, work 24 hours a day, and they involve every cell in the body. How did the word cell originate? In 1671, a Dutch scientist, Antony van Leeuwenhoek, was examining the skin of an onion under a microscope. The rectangular shapes he saw reminded him of the local monastery and the monks' tiny cells. He realized that all plant and animal life is made up of similar tiny cells. In fact, the human body has 60 trillion of them. Laid end to end, they would stretch from London to Aberdeen. And all are vulnerable to attack. From the food we eat, the fluids we drink, and the air we breathe, the body is constantly bombarded by organisms that can cause illness. So one type of cell is specifically designed to fight back. White blood cells roam the body, killing and eating anything that threatens it. They're minute, but deadly to their enemies. Some cells in the gut live only 3 days, while others in the brain live with their owner an entire lifetime. And millions are dying and being born every second. Your finger has more cells than the number of people in the world's largest city. And just as that huge city would be paralyzed without its web of communications, so the human machine is coordinated by a network of its own: nerves. Like the telephone system, nerve signals are electrical. The body has around 45,000 kilometers of nerve cables carrying messages and coordinating everything it does. For thousands of years, the Chinese have believed they can control the nervous energy of the body through acupuncture, inserting fine needles into precise parts of the skin to treat different illnesses. And the entire network, in fact the entire body, is run by one small but perfect control center: the brain. In relation to body size, the human brain is the largest of any animal. And it's unique, the only brain in the animal world intelligent enough to study itself. Together with the spinal cord, the brain has more nerve cells than the number of trees in the Amazon rainforest, and as many connections as there are leaves on those trees. So important is the brain to survival that although only 1/50th of the body's weight, it receives 1/5 of its blood supply. The brain is made up of sections with a job to do, each organizing and controlling its own body area. If the size of each body part were related to its controlling area in the brain, we would all look very different. The brain even organizes memories into 3 departments: those retained for a split second, those kept for around 5 minutes, and a main bank stored for a lifetime. The brain constantly saves space by erasing unnecessary memories. If we could remember the whole of our lives like we can the last minute or two, we get very confused. Given its power, there is little wonder that throughout history humans have built up superstition, legend, myth and magic around this massive tissue. Ancient warriors even ate the brains of slaughtered enemy chiefs to gain their wisdom. It's not the heart, but the brain that dictates our emotions, our consciousness and love, our understanding, our passion, and the desire for one another that leads to physical bonding. To the moment of fertilization between a sperm and an egg that heralds the creation of a new body, a new brain, a new life. Unique among machines, this one can reproduce itself. Improving, developing, through nearly 1 million years, generation after generation, we've evolved beyond our forebears. We've learned to do more than survive. We've learned to play, to dance and sing, to speak and teach, to reason, to show emotion, and to love. And how do we show these human feelings? Here, in our faces. It's this unique alliance of brain, body, feeling, and expression that makes us different. We can laugh and cry. We are sadness and joy. We are reason and passion. We are human.